In this video, we will find the probability of getting a straight flush in poker. So this example says that a poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains 5 cards of consecutive ranks, all of the same suit. And don't simplify your fraction that you get at the end of the problem. So when we have 5 cards of consecutive ranks, all of the same suit, that is called a straight flush. So let me explain what this means with an example. So 5 cards of consecutive ranks, that just means the numbers are keep going up by 1. So like 2, 3, 4, 5, 6. And they all need to have the same suit. So one example would be if you had a 2 of diamonds as one card, and then a 3 of diamonds as the next card, and then a 4. So notice the rank, which is the number, keeps going up by 1 each time. 4 of diamonds, and then a 5 of diamonds, and then finally a 6 of diamonds. So 5 consecutive ranks, and they all have the same suit. In this case, the suit was a diamond. So that's an example of a straight flush. So there's one important note that I want to make. So in poker, an ace can either be considered as like the lowest possible rank, so below a 2, so it's kind of like a 1. But an ace could also have the highest possible rank, so even larger than a king. So the face cards like Jack, Queen, and King, when they're written in this order, for example, I think of Jack as 11, Queen is 12, and King is 13, and then ace would be even bigger than that when it's all in this order. So if you did have these 5 cards in that order, and they all had the same suit, in poker, this is really special. This is called a royal flush. Flush. And usually, a royal flush is a special type of straight flush, but for the purposes of this question, I am not going to be considering this as a straight flush for this question. I'm going to consider a royal flush as a separate entity. All right, so that said, let's get into the problem. I want to find the probability of getting a straight flush. So using my formula for the probability when I have equally likely outcomes, I know I'm going to get a fraction. And on the top, I need the number of successful outcomes. And in this case, I have a success if I get a straight flush. So the top is going to be the number of straight flushes, the number of different types of straight flushes that we could have. And on the bottom, we have the total number of outcomes. In this case, in this problem, the different outcomes are the different sets of poker hands, the 5 card hands that we could be dealt. So the denominator is the number of poker, let me say the total number, the total number of poker hands. All right, so let's focus on each of these one at a time. So maybe I'll focus on the numerator first. So let's talk about strategy for the numerator for the number of straight flushes. So there's 2 parts to getting a straight flush. One is I need my sequence of 5 consecutive numbers. So I need to pick a sequence of 5 consecutive numbers, or sometimes we call these things the ranks. So for example, if I made the ace the lowest ranked, kind of like a 1, I could have ace 2, 3, 4, 5. Okay, if I increased everything by 1, I would have 2, 3, 4, 5, 6. And I could keep going like this. I could do 3, 4, 5, 6, 7. And how high could we go? Well, I mentioned in the note at the start of the problem that I don't want to consider a royal flush as being a straight flush for the purposes of this question. So my lowest card, I don't want to be able to have that be a 10. But let's go one smaller than a 10. What if I started with a 9? And I could do 9, 10, Jack, Queen, King. So these are all the different sequences of numbers that could give me a straight flush. So if I count these, focusing on the first number at the front, I think of the ace here as a 1, and then it's kind of like I have a 1, a 2 at the front, a 3 at the front, up to a 9 at the front. So there are 9 ways of picking my sequence of consecutive ranks. And the other part to getting a straight flush is I need to pick the suit that those 5 consecutive ranks are going to take on. So I need all of those to have the exact same suit. And there's 4 choices of suits, because you could have the red cards like diamonds or hearts, or the other 2 suits are the black ones, clubs or spades. So in total we have those 4 choices. So we are ready to write down the number of straight flushes. The number of straight flushes, because we just multiply those numbers together. So 9, and then times the 4, and that gives us 36. So I'm going to highlight this. We were counting the numerator, the number of straight flushes, and we just found that was equal to 36. So let's find the denominator now, the total number of poker hands. It turns out this is actually easier to find. Total number of poker hands. So with the poker hand, I need to select 5 cards from my deck of 52. And the order in which we pick the cards doesn't matter. So we're going to use a combination. And we're going to be choosing 5 cards, so I'm going to put a 5 at the bottom, from my deck of 52 cards. So we put a 52 at the top. And that is the total number of poker hands. Let's highlight that as well. So total number of poker hands is 52, choose 5. So we are ready to set up our probability fraction. Probability of getting a straight flush is equal to the number of straight flushes on the top, which is 36, and the total number of poker hands on the bottom, which is 52, choose 5. And using a calculator to evaluate 52, choose 5, we end up with 2598960. And at this problem at the start, it did say at the end, don't simplify your fraction. So it's just fine if I leave our answer like this. If we did plug this into a calculator to work out what it is as a decimal, and if we converted that decimal to a percentage, this ends up being about 0.0014%. So a really small chance that when we're dealt 5 cards, it ends up being a straight flush.